We're going to go over this graphing of a periodic function, and we know this function, g at x, is periodic because it's a sine function. So the sine function usually takes this view when we're looking at it, right? So we know it's periodic. One of the things we could do is we'll actually start by putting in the 5 major points for a sine wave. Now this is in radians, so we'll write the 5 major points in radians. We'll just put them here below. We know one of them will be at 0, 0. Another one will be pi over 2 and 90. Another one is pi and 180. 3 pi over 2. And, oh, sorry. What am I doing? I was writing the degrees in here. These are the y values. This is 1, 0, negative 1. And the last one is 2 pi and 0. Okay, so we'll start by actually graphing those. We'll go on the assumption that this is the scale here. Every 2 blocks we'll say is about a unit. So we have one coordinate here, another one here, another here, third, fourth, and fifth. And we'll try to just fit a curve to it, because we're filling in the continuousness of the curve. What we're going to do is we're going to take a look at all the potential variables that can transform this function. So if we have a function like this, we usually have variables for a. We know it's a sine wave, so we'll write sine in. Then we have b, x plus c, and then plus d. So we're just going to fill in those variables, and then we're going to go through the process of figuring out what a, b, c, and d are. So in this one, we know that our a value, it's in front of sine, will be a half. So we know we're going to have a vertical stretch. Actually, in this case, because it's a half, you can consider this a compression, actually. So we're going to put the letter c there. So it's going to compress it. In other words, what will happen is, if this was the original wave, the new wave will be less pronounced. The maximums and minimums won't go as far. The amplitude of the function won't be as high. Okay. Our b value, which has to do with horizontal stretches and compressions, they don't actually have a b value here. There's nothing being multiplied in front of this. So in this case, the b value is 1, which means the period of the function is just going to stay the same. In other words, it's going to take 2 pi to go through the entire period. The period doesn't change. Our c, which has to do with horizontal translations, okay, says negative 3 pi over 2. Okay, and think of that as if it was degrees, as like 270 degrees. Because it's negative, it's actually going to go to the right. So what we would say is if this was our original function, it's going to go, since from here to here is about 260, the new function would start here and then go through the same process. So we have this shift to the right of the function. And then finally, the d value is vertical translations, and we have plus 1. So what that means is our function is going to go like this, and everything is just going to move up the y-axis 1 value. So with all that being said, we'll try to go through the process one step at a time. It's usually easiest to actually apply the transformation or the stretches and compressions first. So the very first stretch was a. What you can do is you can take all the y values here and recall that these are the y values. So this one is, I'm just going to write the y values in, 0, 1, 0, negative 1, and 0. And we multiply them by that a. So we multiply by a half, multiply by a half, multiply by a half. Same idea all the way through. When we do that, the zeros stay at 0. So in other words, these coordinates, they don't change on the y-axis. But these ones go from the value of 1 to a half. So the maximum is lower and the minimum is a little higher. So our curve gets this vertical compression to it. So that's the very first one. It's not as high as it was before. We said the b value doesn't change anything, so we're going to leave that. The c value here, it actually affects the x-axis, okay? So our x-axis happens to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And what's actually happening here is we're subtracting, so we're shifting to the right. We're actually adding 3 pi over 2 to everything, 3 pi over 2. And one of the ways we can do that is just take the 0 value, and we're going to move it right to where 3 pi is. And then from there, it looks like 1, 2, 3. So 1, 2, 3. Our next coordinate would be up here. So the function we know is going to go up, and it's going to continue somewhere out here, but we don't have any more graph to draw it on. So we're actually going to continue in the reverse direction here, just to figure out what the graph will still look like in the parameters we have, because our parameters, the domain of this is between 0 and 2 pi. So it actually would head downwards and back up again. So the green one, we've applied both the A and the C. So we've done A and we've done C. And finally, the last transformation here is the vertical transformation. And that's, again, the y values. We're just going to add 1 to all of them. So we're going to take each of the y values from the green one, and we're just going to shift it up 1 unit. So this one goes from 0 to 1. This one goes from -1 to 0. This one's from 0 to 1. And this goes from 1 to 2. So we get this type of a curve. So the yellow one is where we've applied all of the changes to it. So the yellow one would actually be our final curve in this specific question.